Hello. Yeah, how are you? Yeah, yeah. Yeah, I'm about to start class right now. So can I get back to taking I'll be taking a break from okay, we'll see. Let me just get back to you. We'll see what's going to happen. Where was that? Yep. Alright, no, 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 no. Let me just get back to you because I'm kind of busy right now. Alright, yeah. I don't know what I'm looking for. Alright. You come from the. Ok, partager l'écran. Oui, oui, oui. Hey. You able to get me?
Yeah.
Okay, so we'll start our TV. I hope we all managed to do one or two things. Before I forget, I actually suggested that all the video what should be on. I'm only seeing a few individuals. This is what this is the TD. So yeah, it will be best if I'm able to see if I'm interacting, right? Okay. Okay. We still have people that have not yet switched on their videos. Okay. All right. Well, unfortunately, only one person was actually able to send some feedback, or rather, was able to respond to some few questions. So the first thing is, I want to get it from you guys. Did you understand all the questions that I sent you in the TD? Be very free. I want to know. Did you understand? I want you guys to tell me the problem too, as in to why you weren't able to solve anything yesterday. Because only one person did so. I'm waiting for a response. Ruben, why didn't you solve the questions that I sent you? What was the problem?
Just wanted to say the truth. Didn't see them. Didn't
Sorry?
go.
You didn't see the TD?
No.
This is weird. Okay, that's Ruben's point of view. Mulenga Chewe, why didn't you do my TD?
Video.
I only have one person that did the TD, and it's going to be very difficult if you guys don't want to try out something. I only have Banda. Banda is the only person that did my TD. And it was so unfortunate, like, he actually got everything correct. And I would have actually I loved the fact that at least somebody was able to write and give me a feedback and got everything correct. Because to be honest, I don't know if Mono told you this. What we just actually did was just basics. We haven't even started solving questions. Rather, I wish I doing analysis. But just basics, like I would say in like the 7 week, that's the introduction part. So I was expecting a high participation from you guys. The next time I see this, if you don't try out, I'm not going to allow you to enter my class again. So if you don't understand a part, it's better you tell me before I close the lesson. Or if I send you the TD, you don't understand. Wi-Fi is very cheap in Morocco. Text me, call me, oh, NS, I have a problem, I didn't understand this, but I explained to you the questions, you try them out, and then as we come and start solving the TDs, you understand better than you guys just keeping quiet, and then you expect me just to suppose that you guys actually got something. I don't like people to suppose. I know my mode is to do supposing, but I would prefer you guys at least to try out your best, your level best. There was a question that was posed. I don't know people that are doing pharmacy. Before I start the lesson, people that are doing pharmacy, I'm told there's analysis. You cannot solve analysis if you miss some part to say there are only certain topics that are there. Otherwise, you have to start from the word go. You just can't start on the middle and then yeah, you're there and then boof, you start solving analysis. Analysis are steps. So if you don't understand every step, you're gone. I hope. Where did you finish your course in the morning? Did you manage to complete all the topic?
No, we didn't manage.
I didn't manage. Okay, so where did you end? Where did you end? Hey, where did you end, you guys? Mukwa.
We ended on the
Bond superior.
yeah.
And bond inferior.
Superior. So you perfectly understood what majorant is and what minorant is. I'll ask you a simple question. If I have a set or an interval that has got, you can be writing down. One day I wanted you guys to make the video. I want to be seeing you writing. Those people that haven't turned on their videos, I'll remove you out of class very, very soon. I'm sorry. Yeah. You just stop listening to the lesson and then that will be the end. C'est mieux comme ça. Merci beaucoup. Vous êtes très gentil. Voilà. C'est ça. Okay. So if you have a set, suppose you have a set of a closed set with 0 and 0,1. You're writing down. I hope you're writing down. You have a closed set of 0 and 1. So it's 0, positive infinity. And then you open. You open. Are you able to understand?
Can you repeat the second one? The one
Repeat it.
Okay.
Just repeat from the start.
Okay, let me try to do something. Reverse side decree. Okay. You have, for example, you open, comme ça. You have 0, virgule, positive, infinity. You open, comme ça. What is your minorant in this content that we have here?
It's 0.
0.
Yeah? And what is your
0.
majorant? What is your majorant?
Majorant,
We don't have a majorant.
Très bien, très bien, très bien, très bien. Very, very happy. What if here we put 2? What's going to be our majorant here?
2.
2.
Very bien. So what's the difference here? Why should we say we have a 2 here? Why should we allow 2 to be the majorant and not positive infinity?
Here.
2 is specified, while positive infinity is not. So it means the numbers continue going on and we don't know the greatest.
Yeah. Wow. This is good. I'm happy. You guys are going to perform wonders. Okay. This is excellent. What if we have negative infinity? Have a 2. So we have alpha is less than negative infinity, which is less than or equal to 2. In this case, what's going to be our majorant?
2.
And our minorant?
Don't have.
We don't have. Because the infinity is undescribed, hence we don't know the least value, because the figures keep going and on. Hence we don't know the least minimum value.
Very bien. Okay, that's excellent. That's excellent. Okay, so in that case, I believe that you guys have perfectly understood the lesson, and I'm happy. Okay, for bond superior and bond inferior, I was actually told to do some questions with you, so probably also you're going to have a better understanding on on those two. So do we have any questions so far? Any places that you didn't get to understand during the course? Sinon, we'll start solving the first question. So the first question we have is démontrer que si R appartient à la nombre rationnel et X n'appartient pas à un nombre rationnel, alors R plus X n'appartient pas à un nombre rationnel. Et si R n'est pas égal à 0, alors R fois X n'appartient pas à la nombre naturel. Can someone try to, like, does anyone know what is going on in this question? So the question in English is saying, we show that if R belongs to rational numbers and X does not belong to rational numbers, and then we have R plus X, these two, they do not belong to rational numbers. Pourquoi? Because we have one of the coefficients that we have here, which does not belong to rational numbers, and the other one that belongs, but we suppose that when you add this and this, it should not belong to rational numbers. And if R is not equal to 0, then we can say R times X is not equal, does not belong to rational numbers. So what are we showing first of all? We have to show this statement that we have here. Donc, on va essayer de démontrer cette proposition qui est ici. Who has got any ideas on how we can show this demonstration that we have here? Renzo, Namanji, how do you think we can come about, how do you think we can try to this? What ideas that you think we can use here? Analyze, every time you're solving analysis, you have to be open. You have to have an open mind. Every idea is correct. It's just what makes it wrong is the way you put it, I can say. So, Renzo, Namanji, how do you think you can go about that question? Pardon me, I'm really bad at pronouncing people's names. I don't even pronounce my name that well. So, you pardon me for that. Renzo, any ideas? C'est pas grave, c'est pas grave. We have Jack. Do you have any ideas, Jack? Be very, very free. We, Jack.
No, I don't have any idea on this.
Okay. Do you have, I've forgotten the first name, Banda, is it Jacob? Jacob is here, right?
I think John.
So is Jack is not present?
Banda John.
No, John Banda, John Banda. Sorry, John Banda. Yes, John Banda.
We are told R is rational and X is not rational. So, okay. Sorry, unfortunately, I can't open my camera. I'm having issues with my PC. So I'll just explain like this.
Okay, okay.
We're going to say since R is rational, then we are going to take it is equal to R is the same as P over Q, with P coming from integers and Q coming from natural numbers, except
okay. Just there. Okay, you continue. The first thing that should come about you guys, every time you see a question like this is this. What is a what? A rational number. How do you present a rational number? Isaac, how do you present a rational number?
Sorry, no idea.
Okay. How do you present a rational number?
Can I respond?
Form of a fraction.
In the form of a fraction. So we can suppose that a fraction that we can have that we use generally in analysis is what? The one that we are using during the course?
A over B.
A over B.
A over B or P over Q. We can use A over B or P over Q. So in actual sense, the first thing that you have to look at is, okay, in the first statement that I have here, if R belongs to rational numbers, this is to say that R is equal to what?
A over B.
A over B. Très bien. And if X does not belong to rational numbers, this is to say what? X is equal to what?
Go to C.
Sorry?
X.
X. Our X is going to be equal to what?
An irrational number such as square root of 2 or pi, something like that.
Okay, I didn't really get that. We'll go direct to solutions. So my solutions that I try to work out were, so we suppose that since we are saying R belongs, you can be writing down this, very, very important as I'm explaining. Probably you should also get the most important points that I'll be explaining. Are you able to see the screen very, very clear?
Yeah.
Yep.
Yes.
Okay. I'll be going very bit by bit because this is this is the most important part of book. So I don't want anybody to miss, to not capture any point. Something here. So we have soit R. I don't know, I can't see. Okay. Sorry. Donc, soit R égale à P sur Q, when we are saying this belongs to rational numbers, and X does not belong to rational numbers. Donc, par l'absurde, c'est quoi par l'absurde? What do we talk about absurde? C'est quoi? On dit absurde, ça veut dire quoi?
On the contrary.
Sorry?
We say like on contrary.
Contrary, voila. So I just saying, oh, contrary. So what is contrary in simple terms? Contrary is what? It's the opposite, isn't it?
Yep.
N'est-ce pas?
C.
Donc, we are going to say X does not belong, which is the contrary of this, and perhaps we suppose that R plus X belongs to rational numbers. Alors, il existe des entières. So we're going to suppose that there is an existence of two natural numbers, which we are going to call P prime and Q prime, such that when we add R, we said it was equal to what? We said R was what? Was the P over Q, and these belong to rational numbers. So if we say R plus X is equal to P prime over Q prime. Pourquoi? Because we are saying the X that we have in this case here doesn't belong to what? To rational numbers. So we're going to just suppose that when you add R plus X, because it does not belong to rational numbers, we're going to call it P prime over Q prime. Donc, we find the value of what? We find the value of X, because in this order we don't have we don't know what X is. We have already been given what R is. So what is X there? Therefore, so X that we have therefore is X is equal to, we are going to take this, the R, we take it this side, it's going to be negative. So we're going to have X minus R. R is what? P over Q. So we're going to have X is equal to P prime over Q prime minus P over Q, which is equal to, we solve this fraction, we're going to have Q P prime minus P Q prime over Q prime. And therefore, after this, we can describe to say, okay, this supposition that we have here, because it was parabsurd, we can say, okay, this one, therefore, belongs to rational numbers. Ce qui est absurde car X does not belong to rational numbers, because this fraction that we have here, it actually, in common sense, does not belong to rational numbers. Par absurde, of course, the contrary of this, it is to tell us, say, X does not belong to rational numbers. De la même façon, si R fois X appartient à un nombre rationnel, alors R fois X égale à P prime sur Q prime. We are going to replace here with Q over P, and then we are going to multiply everything, and we're going to get the value of X. Ce qui est par absurde, which is the opposite of actually the normal function of saying X being a fraction of maybe A over B or C over D or V over Q, dans n'importe quelle condition. Et après ça, fait, you have solved the work. That is exercise 1.
So Hello.
Oui, je suis ici.
Yeah, I had network problems, so I couldn't understand. I couldn't see what you did. Starting from where it is written, it exists, do, and I couldn't get what you said.
It exists. Where is it exist? Here. Okay. So the first thing that we said was, we know in mind to say if R belongs to rational numbers, P, we can say, okay, we'll suppose that P over Q, because you know rational numbers are in form of fractions. Okay. Okay, there. And if X doesn't belong to rational numbers, meaning that X should not be in a form of a fraction. N'est-ce pas? N'est-ce pas? What do we know? Right there. Donc, par l'absurde, we suppose. Donc, par l'absurde, we are going to suppose that R plus X appartient à Q. But because R has already been defined, and we defined R to be P over Q, okay? So we're going to put here already, we have what R is, which is P over, which is this part here. We're going to put it here. So it's the same as saying P over Q plus X. And this V belongs to rational numbers. So if it's per absurd, we're going to suppose that if this is true, we're going to say, okay, R plus X it appartient à la Q. Q is rational numbers. But because we have P over Q already, we're going to say, we suppose that this here is P prime over Q prime, which is this here. That's how we came here. We said that means to say R plus X is equal to P prime over Q prime, which is this particular rational number that we have here. Okay, so if we have R plus X is equal to P prime over Q prime, we already have what R is, but we don't know what X is. So we are going to find what X is. R is P over Q. So we're going to say X is equal to P prime over Q prime minus, we're going to take this R this side, we're going to have minus P over Q. We solve this fraction, and because we have a form of a fraction here, automatically this qualifies to be what? To be what? A rational number, n'est-ce pas? Put in mind that we suppose that this is by what? Par l'absurde. Ce qui est absurde car X n'appartient pas à un nombre rationnel. It's par absurde, attention, it's par absurde, just la contraposée de la fonction normale. Because here we are putting to mind to say that X does not belong to rational numbers. It's just like the opposite. We are supposing, there's a very, very important verb to use here. On a supposé, pardon. Voilà. C'est ça qui est ici. So, de la même façon, if we, for example, again introduce the multiplication, si on dit R fois X, la même chose, qu'est-ce qu'on a fait là-bas, c'est ça qu'on va faire ici. Et on va établir que oui, vraiment, X, normalement, n'appartient pas à un nombre rationnel, mais par l'absurde, oui, ça appartient à un nombre rationnel. Et c'est ça qui est ici. C'est bon?
Oui, c'est bon.
Okay.
Just a minute.
Oui.
What did you say the word absurd means in terms of the same calculation?
Contraposé, c'est la contraposée. You got it?
Sorry, I didn't get you.
Contraposé, c'est la contraposée. Contraposé, you said contraposé, like opposite. It's like you find the opposite way to solve a certain question. That's per absurd. It's like you're showing something. You have been, for example, this question has been given to say this doesn't belong to this. So how do you think? And when you're doing an analysis, you have to think that, okay, in my question, if they're saying this does not belong to this, how can I solve such a question? You solve it by saying, let me suppose that it actually belongs to what I've been given. That's how you solve the question. Okay? So that's par absurde. That's how par absurde comes about. C'est bon?
All right, Ebo.
Okay. Is it clear? We don't have any questions, right? Yes. I normally give exams, so I'm going to give you an exam after the first topic. Yeah, sort of an exam, just an assessment, continuous assessment, so that I know how you guys, at what rates you guys are moving with me. So after this, I'm going to send you some nice questions, just an assessment, so that you can try to see where you are personally. Okay.
Yes, I've got a question on the la même fraction, like a dot. Is it multiplication or what?
Multiplication. This is multiplication. Every time you see a dot in French, like for example, in this situation, it shows multiplication. You never find the times in Morocco. Fois, the point that you have there, it's a multiplication.
All right.
C'est bon?
Oui.
Okay.
And
No, any other question?
It's not a question. Just asking if you can just repeat. As in, kept on disconnecting. I'm having some technical difficulties.
Sorry, I couldn't get you.
Oh, I don't know if it's okay if you can just repeat the first part. Kept on disconnecting.
You're the one that's inbox me right now.
No.
Okay. Okay. So for the last time, okay, someone has raised the hand. Let me just get back to what our brother said, and then if you can come in, I'll give you a chance. Sorry?
That's the mistake, sorry.
All right. Okay, so one of our friends that had network problems. So we are saying the first thing that you have to look at is the question that we have a question that is saying R belongs to rational numbers. So what's the first thing that you have to look at? You have to say, okay, what are rational numbers? So we said rational numbers, these are numbers that are in the form of a fraction. So we suppose that P over Q was our fraction, and because we are told in the question that X does not belong to rational numbers, so what X values are, we're going to use the opposite of this. So if we have the opposite of this, we're going to use a fraction that has the original function, and then we try to attribute it with the opposite of the other value or the other form that we have, and that's how we came about it with la form absurd. So we suppose that R plus X belongs to rational numbers. So the decay we have already R okay. We have already R plus X, which qui appartient à nombre rationnel. Alors, il existe des entières P', P' et Q'. Somebody has asked, what does prim stand for? I said last time, what prim stands for? Here you can observe here we've got P and I've got Q. We cannot again put PP. It's going to mean that we're going to cancel everything here. Okay, so this prim is just coming about to say it's in a different form. If you want, you can put X and Y. It's a paragraph, but I just use P' and Q' to show that there's a difference between this one and this one. This is the R value, and this one is the rational value. So bon. But if you want, you can put X or you can put R. This prim, don't try to confuse this prim as when deriving function. When you start deriving function, it's going to mean something else. But for now, it's just in simple terms. I'm just trying to say, okay, this actually may mean X, may mean Y, may mean V, may mean W. Okay, I hope we are clear with that, because somebody just asked me to say, what does prim mean? Yeah, so for now, it's just like, I just don't want to be using the same PQ. Okay, continue. Donc, P' et Q' tel que R plus X égalé à P' sur Q'. Donc, X égalé à P' sur Q' moins the X, the R, because R was taken this side, we have P over Q. And if we solve, because we have a form of a fraction here, This means that these oui, vraiment, they belong to rational numbers. Pourquoi? Parce qu'on a fait par l'absurde. On a supposons par l'absurde. Ce qui est l'absurde car x does not belong to rational numbers because x, oui, vraiment, n'appartient pas à un nombre rationnel. Donc, we have proved for r plus, in the first case, we are proving for r plus x. What of if we have r times x qui appartient à q? Alors, ici, c'est la même chose, le même principe. We already have what this is, we already have what this is. We multiply everything and gives us this. Same stuff that we're using par l'absurde. Donc, c'est ça. C'est ça la but pour la première question. Est-ce que c'est bon?
Oui.
Oui, c'est bon.
Oui.
So somebody put a comment. So because x is not a member of rational numbers, makes r plus x not a member of rational numbers. Oui. Oui. Question 2. What do we have for question 2? So question 2, we are showing that donc je vais supposer que so question 2 and question 3 we're going to pass because on the deux, c'est le même principe. Whatever we're going to solve for question 2, that is on question 3. We're going to pass to question 4. Are we okay?
Just before you proceed, can you hear me?
Oui, oui.
Yeah, so which one is the final answer there? The first one or the second one?
Which one is the answer? Where? This is the whole answer. Everything is the answer. We are just showing. Okay? It's to show. You only find a specific answer if you are, it's like in those people used to take, what's this? Addition of the mathematics. When you have to say show or prove, you just make a proof of something. But there's no any final destination. The final destination that you have here is actually here, but it's just showing. So it's about you telling the professor, like it's just a kind of an analysis on rational numbers. So I telling the professor, say, okay, I understood rational numbers, and in general, this is what we've shown, or this is how we can describe by rational numbers. So everything that is here is the answer. So you have to write. No wonder I was saying, and this is how you answer questions. Even in your exam, you expect you to answer like this. If you just write r is equal to this is wrong. It's 0. Maybe the prof is going to feel sorry for you. Just going to give you maybe if it's 2 marks, he'll just give you 2.5 maybe. If you like, some will just make it wrong and they leave you.
Okay, I have a question as well.
Oui.
Does it mean that since we found
oui.
x, let's say q p prime minus p q prime over qq is a member of rational, and since we said absolute is opposite, so is that satisfying to say we take the opposite and then we conclude to say x is not a member of rational?
Oui. Oui. Because here the question that is like from the question we're saying x is not a member of rational numbers. Okay, so how can we find like for x to be a part of rational numbers? Just by us saying the opposite, that x, we suppose that x is a rational number. Okay, that's what we suppose there. If we have x does not belong to rational numbers, for us to find what x really is by doing the opposite of saying x belongs to rational numbers. But how can we find that? It's by using what you've already been given, r and the q, by definition. Wait. Does someone have a question?
I have a question.
Okay, let me fix my.
Are you getting me?
Wait.
Yeah. So, Mr. Ernest, you mean?
Yes, I can get you. My network is. Wait.
Yeah. You mean like this whole solution is okay? We can even prove it using real values.
Yeah, we can prove it using real values, but real values will be giving you digits, which you don't want. The concept here is that you showing. Okay. Yeah, because if you're going to start using values, that will be the case whereby Renzo is going to use 4 and 5. Lawrence is going to use 6 and 8. So professor is going to get lost because they're going to be finding certain values and then be like, okay, which value is really correct? And now it's best to use letters because letters we all have the same concept. Okay.
I'm finding some challenges to prove it because I was supposing to say, okay, first of all, will you agree with me to say all whole numbers are rational, right?
Pardon?
All whole numbers. All numbers. Are you getting me?
All numbers are what?
Whole numbers. 1, 2, 3 are rational, right?
Ruben, this is Ruben.
Yes,
If I'm not mistaken, that is saying that is on the floor. Ruben, what's the rational number?
A number which can be expressed in terms of A over B. Hello?
Excuse me, Mr. Ernest. Can I try and explain to Ruben?
Yes.
Okay, Ruben, here the thing is that we are given x is an irrational number and r plus x is not a rational, doesn't give us a rational value. So yeah, we assume that when this gives us a rational value, so we just like assume that, then while we are assuming, we made x the subject of the formula, and yeah, we discover that when we discover that this operation there gives us a rational number, then we make x the subject of the formula. We find that x will become a rational number, and we've been told that x is irrational. So yeah, it contradicts to the question. The value of x we find contradicts the question. So that means it's irrational. You get my point?
Yeah. Like my question was, the whole solution here, can we prove it? Then Mr. Ernest said yes. So I was imagining that in my mind thinking to say, just supposing that R is 2 and 2 is rational, right? Then pi is irrational. You agree with me?
Yeah.
Does it mean 2 plus pi is rational like the statement is saying?
Okay, here the thing is that we are supposing. It's not like, for us to get this value here, we just like supposed. We didn't like, it's not the real value. We just supposed. So after supposing, we went on to find that if we suppose that r plus x gives us a rational number, then we discover that x becomes a rational number, and we are told that x is not a rational number. So that means that it's not possible that we can have x as a rational number, which we've been told that it's not. So that means that value of x is wrong, and we can't take that. So yeah, we conclude that if it's not rational, if it's not rational, then it's irrational.
Okay.
Bon. Okay, sorry. I really had problems with my network here. I don't know if you're able to get me.
We can get you.
Hello, Onela. Okay, coming back. Sorry, I was trying to answer Ruben. I lost some contact here. Okay, Ruben, what is your question? Sorry, or somebody has already answered.
Lawrence can help me. Lawrence understands my question. Lawrence.
Okay, so what you've been saying is according to the question, if we have a rational number plus x, which is an irrational number, our value should still be rational, isn't it? Hello? Well, can you hear me? Yeah, so for example, if we have pi, let's say 3 plus pi, which is pi is 3.142. So our value will be 6.142. So the question is 6.142 a rational number? That is what we're trying to prove.
Seems like it's gone again. Oh yeah, the thing is that Lawrence, here the question says that you see there it says r plus x is not a member of the rationals. So yeah, it's not rational. So the value found is not rational. But to prove, we just assumed, like, it's not that we've made it a rational number, but we've just assumed, like, the way things would go if the
Okay,
answer was
I think
rational.
is it okay now?
Okay, yeah, it's okay. Since r plus x is still irrational, we thought it was rational.
Are you able to get me?
Yeah, we can get you.
Okay. Ruben, the concept you're having problems to understand is we supposing.
Okay, I get it. Just supposing, but it's not true.
Yeah, it's not true, just to prove.
You don't know what x value is, you don't know what r value is. Okay, so the concept that you have to put in mind is supposing. I'm going to be supposing. Okay, no wonder we didn't use numbers, because if you start coming with numbers, for example, 6.1 is a fraction. So already that one's going to give you like what, and what's a rational number? A rational number is that of a form of a fraction. When I say don't come about with numbers, because when you work with letters, you'll be supposing. So that here what you're showing is it's not about us finding a certain value or an approximate value. No, what you're finding here is an expression, or we're just showing it. So démontrer. To démontrer is to show. So how do we show it? We show it by saying in the normal question here, if you can come back to the question is saying we have a certain statement here, which is r belongs to rational numbers, but x doesn't. That is to say, if r plus x, this is the statement that we have here. It's just a statement, an ordinary statement that we have here. So this question is trying to tell you to say, okay, if you have a situation like this, a case like this, how can you prove that for sure this can belong to rational numbers? How can you prove that x can belong to rational numbers? You have x doesn't belong to rational numbers here. So how can you prove that x can belong to rational numbers? It's by doing what? By supposing that x, so whatever that you're going to have for x, you suppose that it can actually belong to what? To rational numbers. Remember we said, palabsud on suppose. No wonder I don't like working with numbers. If you begin to work with numbers, you're going to be confusing yourself. Work with the letter that you have here. So the question is saying x does not belong. How do you solve it for you to say it actually belongs? It's by you saying we suppose. Est-ce que c'est clair, Ruben? D'accord. He said it's very, very clear. We are really behind time. Bon, even though some questions don't really solve them, donc c'est pas grave, because there are some things that are just ordinary, and when you go to your schools, that's when you're going to solve them. Okay, So I was saying you did with mono on the square root, right? The province for square root and everything, n'est-ce pas? Il n'y a aucun problème maintenant là. I remember in my first year, this was one of the first questions that I was given the opportunity to go and solve on the board. A province square root of 4. So maybe if you're lucky, if you have a lucky charm, the prof will point at you and you solve such a question, and you know, first impression matters. So when you solve it right on the board where there are 250 people, that will help you. But you know, there are solutions here. I'll probably send them. Are you okay?
Yes.
Exercise 2, I'll leave it for John Banda. John Banda, I want you to explain. I like the way you actually have solved everything, and I would prefer you use your method. So exercise 2 is saying trouver sur la forme P sub Q des rationnels X dont les développements décimaux périodiques sont donnés par 3,1414, 0,999, 3,1499. Donc, I'll give opportunity to John Banda. So John Banda can come in.
Oh, sure. Guys, if you can see those three numbers, they are decimals which are recurring. So if they are recurring, it means when you go to the decimal part, there's something which is going to be same always. So what you do is, let's say for the first one, we have 1414 which is recurring. So you say x, you can be writing for those x equals 3.141414. That's the first thing you do. Then I'm sure you're done. Then after that, you say now 100x. The reason we are saying 100x is because we want to move the period to the side where there are 4 numbers. You'll see why we have to do that. So 100x will give us 314.141414, just like that. So, yeah, that means now, when you say 100x minus x, you can write that as well, 100x minus x. That is going to be the same as 314.141414, going like that, minus 3.1414, going like that. So from there, I think you can see that the periodic size of both numbers, the periodic size, I mean the part where we have decimals, is the same. So when we subtract those two numbers, it's just the same as we are subtracting the 4 numbers now. That is 314 and 3. You see that side. Then this side is 100x minus x, which is 99x. So you say 99x equals 314 minus 3, which is 99. 99x equals 314 minus 3 is 311. So giving us x equals 311 over 99, and we have expressed as a fraction. And we just do the same for the remaining ones. Thank you.
Bon. John, you are done, John?
Actually, I'm done. I think one example is enough.
Hello?
Hello?
Ok, d'accord, oui, oui, tu peux continuer.
Guys, have you understood? I might need to know.
No.
Yeah, it's clear.
No, you can process.
No. I think we need to see how you were solving, like, just
Yes,
show us.
yes. Yeah, I agree with David.
No wonder I suggested you guys to be writing what I'm saying because I have a problem with my PC. I can't activate the camera. I've been trying. So if you guys can just write what I'm saying step by step, that is going to help. Can I start again? Then you'll be
Since earlier with Kelvin in the same house, since Kelvin's camera can work, then you can use it.
Oh, okay. Let's
I've actually sent some responses in the group, so you can just check in the group. I've sent the answers there.
Someone said
So
it's
that you
clear.
can follow as he's explaining.
Okay, so first, if you can see all those decimal numbers, they have one thing in common to say they have recurring, they are recurring decimals. So when solving those, first write this. We say for the first one, x equals 3 point, the same number, 3.141414. If you're not writing, you won't be able to imagine everything, and as a result, you won't understand. So I advise you write this. Then, after writing that, you have a task of converting a period, because that is periodic, means it has periods. So converting a period to decide where we have four numbers. So for this one, we have 141414, which means when we say 100x, it means we are multiplying this number by 100. It's going to give us 314.141414. One of the periods, which is 14, has been taken to where it's 3. That's what we do. So you can write that as well. You understand why we do that. Then, after that, you now have x and 100, of which both numbers have the same periods. So you just say 100x minus x. I'm sure you've written that. Then that is the same to say 314.141414 minus 3. So why we have done all that? It's because we wanted to have the periodic sides which are same now. Like to have my periodic sides which are same. Whereby when you subtract those periodic sides, you just cancel each other. You know. So that 100x minus x is going to be 99x. Then when you go that other side, as we have said, the periodic side will cancel each other. It's going to be 314 minus 3, giving us 311. So 99x equals 311. That's the other thing you're supposed to write. Then you just divide both sides by 100 to remain with your x. Your x now is going to be 311 over 99. That is a fraction. And that's what the question wants. It is saying express that number, that decimal, as a fraction. I don't know. I can have a response if it was clear.
Oui.
Clear.
Très bien.
Yeah, it's
Thank you
clear,
so
but
much,
I've got a question on the third one.
John Banda. Yeah, for the guys that will be doing business, it's not very, very essential for you, but for those that will be going to engineering, very, very essential. Yeah. look at somebody to explain it to the guys. For the guys, since John Banner is even there, you can easily access him. You can actually easily access him, and then he'll do what
We don't need this.
help you in person.
Maybe we just need to understand some things, because for wasting time on things that you want to do it.
Somebody's talking, but I can't really get you. Okay.
It's fine. Let's continue.
I've got a question on the third question.
The third question?
Yeah, like
There's one.
Yeah.
Oui.
On the same questions which John Banda was solving.
Okay, yeah.
Yeah, the third question, like he used the yeah, this one for 3.1499. Like on the part where you are subtracting the what? The 100 x minus x. Now for this one, he used the 100x. But why? Why didn't he just use x alone?
Listen, dude. It's not always that you use 100x. Whenever you are given that question, what should come into your mind is converting the two numbers such that you have the periodic sides which are same. So like for this question, the periodic side is 9999, it goes like that. After 14, it will be 999, even, yeah, just like that. So if you can convert this one, you say x equals, you can write. David, you can write. X equals 3.1499. I'm no longer looking at the question. I need it.
Yeah, I'm getting you.
So x is equal to 3.1499. So what is recurring are those nines. So the first thing you are going to do, you are going to multiply a number with x such that as a result, your answer of the decimal is going to have the periodic part, only the periodic part. So in this case, you're going to multiply this by 100. You say 100x, that will give us 3. Can I see that question? Mr. Ernest. Mr. Ernest, can I see the question?
Sorry?
Can I see the question? Like you...
Okay. Voila.
Yeah. So when you multiply your x with 100, you are going to have 314.9999 because that 9 is recurring. You see? Then when you look at those two numbers, x and 100x, they don't have the same the same periods after the decimal. So in that case, it means you have to multiply this 314.99 again with something so that the
Just a minute. What do you mean by periods? Periodic what?
If you look at the first number, we have 3.141414. That 14 is repeating itself, it's recurring. So we can call it, we can say it's a period. 14.
So it's more like repeating themselves.
Yeah, no wonder there's even that side of recurrence. And continue.
Yeah, you can continue.
So for the first one, for now, when you solve your x and your 100x, you find that the periods, when you look at the numbers after the decimal points, they are not the same. But your task is to make them same. So you say this 100x you have found, you multiply it again with the something, you see. Although the x, when you multiply the x which you have by 1000, so 1000x is going to give us uh, 3,149.99999 going like that. So when you look at those two numbers, 100x and 1000x, they have now the same periods of 99999. So you just do like we did first to say 1000x minus 100x, it will give us 3,149.999 minus 314.999. Then, like, since they have the same periods of 999, those numbers after the decimal points will cancel each other. After the numbers have cancelled each other, it's the same now, like you are just subtracting the whole numbers. And yeah, you can finish from there. These numbers have been.
D'accord. Ok, j'espère que c'est bien fait maintenant. I think John Band has done a very good work explaining. We're going to forge ahead. Don't worry, it's not something very essential. Yeah.
Mr. Enes, sorry, before we move on, would it have been okay if we subtracted another x from, because we are having x which is equal to 3.1499 somewhere there. So would it have been okay if we had?
So I didn't get you.
Would it have been okay if we had subtracted on the third question, the third answer?
Yeah.
If we had subtracted x from, because we're saying 1000x minus 100x, so would it have been okay if we subtracted minus x?
The problem
then
is
this other side
if you had done that,
same.
you'd have found a different value.
Even if I subtracted x this other side and 3.199.
It's the way he had subtracted just the x. Bon, I didn't try. I didn't personally try that, but maybe you should try to do it, and then you should send me your feedback and see how your response are going to be if you had to use a different value. I mean, like an absolute value for x, like the way I've explained it. Okay.
All right.
Yeah, just try to send me in my inbox. Then I try to see how you're going to do it, and then yeah, for those that are not very clear, like I said, you all have my number, and then we'll be able to work on some certain things because we won't be able to capture everything here. Yeah.
And
So
then,
we're going to continue. We're going to go to exercise 5. Very fast. There are some parts that I'm not going to explain to you because I'm still waiting that you finish the topic with mono. So I'm just going. That's how I'm going to be doing it because there's some certain parts that said don't tell them that, don't teach them this because they haven't really done a detailed part. So I'm going to go to a simple to a part that you've already probably done, and I believe that we're going to do this part very fast because we all know what's going on. So exercise 5. Are you able to get me?
Yes.
Okay. So exercise 5, we have déterminer s'il existe, attention, s'il existe, les majorants, minorants, la bonne supérieure, la bonne inférieure, les plus grands éléments, les plus petits éléments des ensembles suivants. Très bien. We have 0, 1, qui appartient à which is a member of rational numbers. So in this case, the first thing that we have here is we find the majorant. We can be writing down what is the majorant here, except for John Banda. John Banda won't be allowed to answer on this one. What is our majorant here?
one.
Attention, s'il vous plaît, s'il vous plaît. Did you understand what majorant is? How can a majorant be one here? Try to look at the question well and try to do the math right there. What's a majorant there? Oui?
What the buddy?
You guys, majorant, we've been doing this. You did this with mono. I even before I said everything, you guys, you are so hyper that you understood. Qu'est-ce qui se passe maintenant? On est fatigué. You're tired.
Mr. Ernest.
Lawrence.
No, it's Davis.
Davis, wait, Davis. What's our majorant?
I'm trying. I'm not sure, but I don't think our majorant is going to be one because I've been told that set belongs to rational numbers, belongs to a set of rational numbers, and hence it's our one cannot be the majorant. I'm not really sure what it is, but I think that's the explanation behind it not being the majorant.
Bon, the concept of one being the majorant is actually correct, but the thing is, like I said, here we have got two cases here. We've got majorant and la bonne superior. So in a situation that we have, for example, in this question, we have to say, what is our majorant? For example, in this set that we're given, the majorant that we're going to have here is the first, the highest digit that we're having here is what? Le majoré here, c'est quoi? Pas le majorant. Mais le majoré, c'est quoi? It's what?
1.
It's 1. So we're going to open and we're going to have 1. So if we have 1 as a majorant, mean that it's exceeding to where? Where is it going to? We have a 1 here, which is like, yeah, so you have your 1 here, which is the majorant in this set. Le majoré in this set, but it's exceeding to what? It's exceeding to positive what?
Positive infinity.
Infinity. Positive infinity. Voila. Let us. You have defined the majorant. You have your 1 here. It's exceeding to what? It's exceeding to positive infinity. So you have written your majorant. That's the majorant. C'est bon.
Yeah, but why are we including the infinity if it's not included there?
We are putting the infinity because we described, how did we describe the majorant? Here, there's a concept that you have to get aware. The thing is, majorant, c'est le plus grand élément. So if we have the smallest element that we have here, already, because we have a closed bracket here, we're going to say le grand, for example, we're going to attribute this as A. We're going to say A is less than or equal to what? Equal to grand M. Why? It's because it's closing here. Okay, but we just can't leave it open like this, because if we're to say the highest element that we have here is 1, but it's a rational number. Rational numbers can exceed, it's not direct on 1. It can exceed up to any different type of numbers that you can have. Okay, so it's like we are starting from a position 1 up to, there's a high chance that we can have numbers up to, we don't know where those numbers are leading us. But because I didn't deal with majorant, we have the least value that we have in this case, say A. So for this question, you're actually going to understand on how we are going to apply bonne superior in this manner. Okay, so it's 1 is the highest value that you are having in this set, but it does not tell you to say that's the highest value that you can go. Okay, the highest value you can actually go to is positive infinity. So when you are told to put the majorant, you have to put the highest value you have in the set, but put in mind also that we can have numbers that may not be in this set. Maybe there's 1.000 quelque chose that can exceed to positive infinity. And that's how you're going to present your majorant. Donc, this is how we present.
So what has induced the infinity? It's because of the rational that we have, not so.
Pardon?
What has induced that infinity is because in the set we have, by saying that those are part of the rational numbers, not so.
Yeah, they are part of rational numbers. Oui.
All right.
Donc c'est ça. This is how we use. I hope you have written down. This is how we use majorant. Donc attention, you just don't leave it very, very open like that and just tell me to say and you keep quiet.
Mr. Ernest.
Oui.
What symbol is that just before the rational numbers, before the Q? Because I'm hearing you saying it's part of. I was expecting to find appartient, but that symbol is different. So what exactly is it called?
We can come back to sets. There is this symbol. There is this symbol. So if we have, bon, I don't know how they write this one. Bon, so we have inclusion. Il y a quelque chose qu'on appelle inclusion. Inclusion. So normally this one is exclusion. So ça veut dire que you are looking at certain numbers that are ranging in a form of like rational numbers. We can use appartient, but in our case we prefer to use this because like
I have a question.
Bon, let me just finish answering that one and then you can come in. Okay, so in this case Jabez, we just use this symbol to mean that there's inclusion, like l'acclusion. L'acclusion, ça veut dire que we're looking at some certain estimated numbers of some certain estimated rational numbers. No wonder we actually came about to say, okay, positive infinite actually can be part of this number that we have here. This exclusion, on s'appelle exclusion. On a inclusion, exclusion.
Right.
So it has nothing to do with intersection.
Bon, intersection, those intersection sets, peut-être, I don't know, peut-être on peut avoir intersection, mais ça va dépendre. Intersection avec quoi? C'est intersection avec la nombre rationnel, mais it's not really going to give good sense if we say intersection. But it can have something to do with intersection, but I don't know how we can use intersection in this, unless you have a general logic that we can use to use intersection in this sense here. Okay.
All right.
Wait. Does someone have the question? Okay. The question is gone. So you people now tell me, c'est quoi la minorant here? C'est quoi? What is going to be a minorant?
Oh yes, it was.
On the first one, the menorah will be 0. The menorah will be just 0 because the line is closed.
You haven't understood. We have here, it's closed here. So we said if we are to estimate ourselves just to say we have one digit value here, we're going to be just around above. If we're just going to say 0 here, it's going to be the same thing like, bon, I don't want to start giving other answers again. Try to get the same concept that I've used to solve this part here. It's the same exact thing that you're going to be using here. So it can't be 0. You just can't say it's 0.
Okay. Yeah. Maybe it's
negative infinity.
Yeah. So we're going to have negative infinity. So negative infinity, what do we do with negative infinity? We open a spa. And what?
Oui.
And 0. Voila. And we close. C'est ça la mineure, pardon. C'est ça. Same thing with what we had here. C'est ça qui est ici. Very, very simple stuff. Okay? Very, very simple stuff. Don't even complicate.
Mr. Ernest, I've got a question.
Oui?
In the first set, those were closed brackets, but we had extended the to extend the majorant to infinity. I thought maybe because it was a closed set, we were only supposed to work within the set.
We only work with that when you look at the interval. You only get to have this when I say present in an interval and a segment. You have to be very, very careful on that. The set you're talking about here, ça s'applique seulement if we deal with intervals and segments. I guess Mono explained what an interval is and a segment is. So us finding the majority here and the minora has got nothing to do with what the sets are opening and closing sets here. C'est bon?
Oui.
So try to go through your work again and understand what an interval is and what the segment is. Majority is and minora is. Okay, it's going to help you open up your mind now. Okay, if there's no question, so what's going to be our bone superior? C'est quoi la bone supérieure ici? Hein?
It will be 1.
Très bien, c'est ça, la bonne supérieure. Regardez, you now understand the thing. Bonne supérieure ici, c'est 1. Très bien. Pourquoi c'est 1? How do you define bonne supérieure? Why is it 1?
Because
oui, oui.
For the non-can, for the major.
What? How do you describe bonne supérieure? What's bonne supérieure?
The minimum number for the majorand.
Voilà, c'est ça. What is your majority here? It's 1 to positive infinity. What's the minimum number that you have here?
It's 1.
Voilà, c'est ça. That's your bone superior. Très bien. And what's going to be your bone inferior?
0.
0. Pourquoi?
Because it's the maximum number of the minora.
Très bien. C'est quoi le plus grand élément ici? Le plus grand élément ici, c'est quoi?
Positive infinity.
Hey, here. Don't look at, let me even up here. Let me even, pardon. Let me even up here so that somebody doesn't say positive infinity. Okay. Here, just look at it in here.
It's 1.
It's 1. That's le plus grand élément. Et le plus petit élément, c'est quoi?
0.
C'est ça. You have solved everything here. Very, very simple stuff. You have solved everything with no problem. That's how you apply majority. That's how you apply minora. That's how you apply bone superior. That's how you apply bone inferior. So if I've solved this, I don't expect you guys to have any problem with this. I expect everybody to be giving me correct answers now.
I've got a question.
Oui.
I didn't get it properly, as in like the meaning of the N, which looks like the intersection.
I said somebody at the so can we say it's intersection? He said, okay, you can create an intersection. I don't know how we are going to describe it to be an intersection. Maybe we can say it's intersecting certain values of rational numbers. But for me, I said c'est l'occlusion. Occlusion, ça veut dire que on peut dire ça appartient à un nombre rationnel. Ok. Ça appartient, c'est bon. Appartient, la verbe appartient. Bon, I have no response. I think it's gone off. We'll come back. We look at the second question. The second question, we have open brackets 0 and 1. This one's for the girls. The girls have been very quiet, so I'm expecting some nice participation from the girls here. We have 0 and 1. Look at the majorant. C'est quoi la majorant qu'on a ici? What's our majorant here? We are here. The girls. That is so. In Mapalo. Oui.
Positive infinity.
Positive infinity.
Positive infinity.
Oui, positive infinity. That's positive infinity.
And 1.
And 1. So you just start, we open bracket 1 positive infinity. Voilà, we close it comme ça. C'est ça qui est ici. Et la minorant, ça sera la même chose. We're going to have negative infinity, virgule, 0. Voilà, vous avez that there. Ça, c'est votre majorant et minorant. OK? La bone supérieure, the girls, this is for the girls only. The girls, what's your bone superior?
Can you kindly repeat the minora? I didn't get you because the network was breaking.
Minora c'est negative. C'est la même chose. We are going to have negative infinity and 0. Here, we have 0, which is going to negative infinity. We've got 1, which is going to positive infinity. So your minora is going to be 0 up to negative infinity. And then you are going to have your imaginary is going to be 1 up to the positive infinity, which is here and which is here. C'est bon? This is negative infinity. Voila. Okay. The girls, la bonne supérieure, c'est quoi?
1.
1. Oui. So I've got your bone superior, which is 1. Your bone inferior?
0.
0.
Oui, oui. Ça, c'est très bien. Très bien. Vraiment très bien. Le plus grand élément, c'est quoi? Ah, what's your... Pardon?
Infinity.
C'est grave. C'est grave. Oh, like, c'est grave. how can your program value be positive? The program infinity is not an element. Is it an element?
1.
No. You can say 1 here. Look what you have got open set here. What did you guys in Mono talk about positive infinity and negative infinity? It's not a value, n'est-ce pas? It's not a value. Ça veut dire que in this set we have no big element, neither do we have a small element. That's the answer. Because we have positive infinity, which is these are open. They are open sets. That's why look at sets now. So we've got an open set here, an open set here. This is going to be negative infinity. This is going to positive infinity. So you cannot say we have a certain big element, and infinity is not an element. Okay, so it's just like an estimation of saying we have a certain number, you don't know it. So you can only have a big number when you have the closed brackets there. When you have a defined interval. When you don't have a defined interval, we can't have le plus grand élément ou bien le plus petit élément. C'est impossible. C'est haram, c'est bizarre. Pas possible. Ok? Donc, c'est ça. This is the part for bone superior. Otherwise, these are very, very simple things. Bone superior, bone inférieur, yeah, c'est pas quelque chose qui sont difficiles. Yeah, it's just a matter of you practicing, trying to solve a lot of questions. If you need questions, I'm always here. I can send you a lot of questions. And then, yeah.
Mr. Ernest. Mr. Ernest.
Je vous attends.
I'm kind of confused on the part where we have a set where there's okay, on exercise 5.
Oui.
Yes, that first set.
Yeah.
Yes, that one. And then the next one that has something like open and okay, that one that is just open.
Oui.
Yes. Now I'm trying to figure out why we are having the same answers for the minora and majora when the things are different.
How are they different? How are they different?
I think the second one is open and the first one is closed.
So I was saying, when you're dealing with majora and you have minora, from the core that you did with mono, you guys are trying to say, because this is open and this is closed. I said, when looking at sets, that only is applied when you're dealing with segments or intervals. C'est bon. You apply that stuff when you're doing segments and intervals. But when you're concentrating on minorant and majorant, you look at what number, what condition you're being given here. You have got a condition that you have here 0, and you have a condition that you have here which is 1. So you look at it, okay, my majorant. If I have a majorant, mean that I'm having a list, le plus petit grand élément. Le plus grand, bon, oui, le plus minimum grand élément. That's what you're going to be concentrating on. So in this case here, we have 1 and we have 0. So if I have my 1 here, means that I can have any sort of numbers up to positive infinity. Don't look at what the brackets say, like, yeah, you have brackets and everything. It's just an explanation that is trying to say the number that are arranging here appartiennent à nombre irrationnel. Okay, but don't start confusing yourself because we have closed brackets here. We are going to use only these certain same values that we have here. So this statement here and this one, in actual sense, because of the values that we are given here, they are the same. Under normal situations, we're supposed to have the same majorant and we're supposed to have the same minorant, or expressions of the same majorant and the same minorant. So this the open interval, I mean the open sets and the closed sets only can be applied when you're going to be looking at intervals and you're going to be looking at segments. Try to go through your polycop again and look at intervals and segments. You're going to understand how those things are going to be applied.
All right, thank you.
You're welcome. So if everything is clear, I expect you guys to actually get to solve this question with no problem. This question here. So we have n, la nombre naturel, moins 1 à la puissance n. This is a defined suite. When you look at suites, you're going to understand this. Plus 1 sur n au carré. Et n n'appartient à pardon. N appartient à un nombre naturel étoile. Ça veut dire quoi étoile? N étoile, ça veut dire quoi?
Exception.
Except what?
Except 0.
Except 0. Très bien. As an exception of 0. So in this case, what's going to be our majorant? Try to solve it. What's going to be our majorant?
I think we don't have the majorant.
Pourquoi?
Because the numbers will continue. We have infinite numbers, infinite natural numbers.
Très bien. Donc il n'y a pas de majorant. What? So if we don't have the majorant, are we going to have the bond supérieur?
No.
No.
Voilà. Donc il n'y a pas le bond supérieur. Oui, ça c'est excellent. Très bien. Là, Ruben. Oui.
Oui.
Are we going to have the plus grand élément?
No.
No.
No, we won't have.
Voilà. C'est ça. Et les minorants? What's going to be our minorant?
Nothing.
Pourquoi?
Because the values, this n, like if you find it, it's going to the positive, come back to the negative. It keeps on going like that.
Attention, Ruben here. For example, in this case, Ruben, if we have, we suppose we have n étoile, n'est-ce pas? We have n étoile. N étoile means we're not going to include 0. So natural numbers, the closest number to 0 is what?
1.
1. So for example, we suppose that n is equal to 1. So we put 1 here. We're going to have negative 1 to the power 1 is equal to what?
Negative 1.
That's 1 over 1 to the power 2 is equal to what? 1. 1 over 1 is equal to 1. So negative 1 plus 1 is going to give us what?
0.
So we're going to start 0. So we're going to have 0 as a up to what? Negative infinity. That's going to be your what is your minorant. So attention avec ça, Ruben. You just can't you can't say because we don't have the same element here. We have an element we have an element that we can actually use for us to scale the mineral. Don't you have exit part? And if we have this, mean that our bone inferior is going to be what? We are going to have a bone inferior. What's our bone inferior? C'est quoi la bone inférieure ici?
0 is the bone.
Voilà, donc bone inférieur is equal to 0. Mais bon.
Ernest, I've got a question.
Oui.
When starting this, the first chapter, you told us that n with a star means like except, meaning there's an exception. So here, where you're including 0, like why are we including 0? Is it that the rules have changed or what?
No. I said there's an exception here. I didn't include 0. I said n being 1. I found 0 when I solved this the expression that I have here.
Okay.
So I didn't include 0. Yeah, I didn't include 0. I said with 1.
Ernest.
Oui.
What is we've got a question on why there is no Le Majora. I think I was lost on that part.
Okay. Ruben, I think at the better explanation. Ruben, prepare Victoria, sir. I don't know, I'm developing to have a bad network again. Now I'm trying to give someone maybe to say that has understood better. Pardon me for that. So I'm trying to fix it right now. So Ruben, can you help me as I try to fix my network here? And then if it's not clear, I'll come in. Pardon me.
Can I get the question cleared?
The question was that why don't we have Le Majora?
Okay. We've been taught to say n is part of natural numbers, right? Now, the range of these natural numbers, it's unknown. It's infinity. It's but starting from 1, right? Natural numbers start from 0, but if we use 0 here, on the left side, 0 won't give us a better thing. Like it will be 0 there, 1 over 0 squared, which is math error. So 0, it's not working out properly. So we can simply say 1 to infinity. So what is the biggest number if I say numbers starting from 1 to infinity? Definitely it's unknown.
Okay. Are you able to get me? Well, there's an error that we made. Pardon me for that. Are you able to get me now?
Sorry, I still have a question, Mr. Ernest.
Wait. No, I think. Yeah, no, I'm saying we made. I made a mistake. Pardon me. Yeah, I observed something. We have actually 2 different questions here. This is a different question, and this is a different question also. Pardon me for that. So I was trying to assimilate this one to this one. So coming to this one, we're going to go with Ruben's response. Oui, c'est vrai. Yeah, okay. So we can come into your question now. Okay. Oui, the question?
My question is that since we have got a set of natural numbers, won't the when we have to start from 1 up to infinity, I thought maybe that would be the Majoran, like just stating infinity. Since the natural numbers have a beginning, which is 1. So
Attention, where natural numbers, where do natural numbers begin from? What are natural numbers? Let's try to first look at natural numbers. Natural numbers from your core. How do you describe natural numbers?
Natural numbers, these are numbers that these are counting numbers which start from 1 up to infinity.
1 to positive infinity. That's how you describe natural numbers. So 0 does not belong to natural numbers.
0, as if we include 0 and those core numbers.
Attention. C'est around. Certain one person I'm talking to here.
Please, can you repeat what you were saying? Funny question never actually, because I lost connection. I was having connection problem.
Okay, so here I'm not only talking to one person. This is very, very important. We're trying to describe natural numbers. Okay, because Ruben had given a point, but the point that Ruben had given is contradicting to one of our brother. That is saying natural numbers actually starts from 1 to positive infinity. Attention, this is a different. This question and this question are different. So don't concentrate on the etwa. They are two different questions. Like I said, I made a mistake. I was actually assimilating them to be the same. So I just dealing with this question here, natural numbers. Okay. So according to Ruben, where do natural numbers start from? We go with this with what Ruben has said.
We are on question 3, right?
Yes, this one here, natural numbers.
Natural number starts from 0.
Voila. Start from 0 up to
positive infinity.
Positive infinity. What of this side? Where do they go to?
All negative numbers are not natural numbers.
They are natural numbers. You call them what? Integers and spam?
Integers, yeah.
Voila. So we have got 0. Okay, 0 to positive infinity. Okay, and then one of our brothers, what you are saying yours, we are starting from 1 to positive infinity. I want this part to be very, very clear, because you can probably have problems as you go to school. So Ruben, what was your justification to say we don't have the Majoran, we don't have the la bonne supérieure, we don't have le plus grand élément? C'est quoi ton justification? I'm trying to
By
involve
definition, you said the majora is like the biggest number in the given, let's say, this set of natural numbers. So since natural numbers start from 0 to positive infinity, now they're asking about the majora. The majora is simply the same positive infinity, which is unknown. That's why I said you don't have the majora.
Wait, is that I think that's the best explanation that I can also give it. It's actually the same with what I also have here. So I don't know where the problem is. How is that part not clear?
It's clear.
C'est clair, d'accord. Bon, normalement, donc si on n'a pas les majorants, c'est obligatoire qu'on ne pas avoir la bonne supérieure, on ne pas avoir le plus grand élément. Et les minorants, ça sera quoi les minorants? What's going to be our minorant?
To be 0. 0.
0 to what? Because they're supposed to be, like I was saying, always you have to put into mind to say, if you're going to say 0 here, it's going to give you the same destination with what is. You're not going to have a proper definition of a bone inferior. Okay, so if it's going to be 0, you're going to suppose that if I have my 0 as my least value that I'm having here, mean that there's an existence of some certain numbers that I may not be aware of. That's going to make me, but of course my main aim that I'm having here is the 0. That's the main objective that you're having here. But of course there might be numbers that are less than, in actual sense, that are less than 0. So I'm not going, I don't know any of those elements that I'm having which are less than 0. So you just have to include the negative infinity there to show that there are numbers that are in existence, but in actual form, I already know that my least value that I'm going to be having in a range that you have, for example, is C, is 0. Okay, so just don't leave it to say just 0. And if you have managed to create this, deja, you are going to have your bone inferior to be 0, and the plus petit element that you're going to have is going to be 0 because it's already a defined set that you're going to be having of natural numbers. So vraiment that's a matter of you trying to understand what's going on, like what are natural numbers, what are real numbers, very, very important thing that you have to understand. Otherwise, nothing new to stress with, because it's very, very simple. Okay.
Mr. Ines.
Wait.
I've got another question. As in let me know how you said that it is what that was a 0. I mean 0, and then there was also a negative to negative infinity.
Yeah. Wait.
But the natural numbers, don't they only involve the positive integers?
Yes, no, I was saying, when you're going to be doing the mineral, that's it car. It's supposed to cross your mind to say, okay, since I'm doing 0, so 0 is your main objective, not that close here. Okay, so 0 being your main objective, you're going to say, if I have my 0 as my main objective, put into mind that there might be numbers that I may not be aware of, but that are being driven to negative infinity. But in actual sense, because we have, if I to, for example, if I to concentrate on the interval that you guys have been looking at, the only value that we're going to be concentrating on here is actually the 0, because it's the one that we are having, which is less than or equal to. The least value we're having, which is less than or equal to. So you suppose that there's an existence of negative values that you're going to be having. But in actual sense, in your mind, you already know that natural numbers, the main objective is on your prof. The main objective that is going to be focusing on is the 0. But you only include the negative infinity, showing to the prof that there's a description of, in these same natural numbers, there's a possibility that we can have a certain group of numbers that are negative. But I don't know where those numbers, negative numbers are. I assimilate them to be up to negative infinity. And that's how I included the negative infinity here, just to make a definite description of the set minoran. Every time you're solving an analysis, you have to think out of the box. Don't just think on a limited part. Always think out of the box. You have to suppose, like we do a lot of supposition in analysis. So as long as you don't manage to think out of the box, it becomes very, very difficult for you. So you have to have the mindset of thinking out of the box every time you're solving questions. There's no question that just comes direct. It's that the prof will give you a direct question. You have to think. Okay. Okay. Yeah. I see people are getting tired. It's very, very hot, unfortunately. Yeah, normally more I started late. I'm supposed to have 2 hours with you guys, but it's already, I've just done 1 hour 46 minutes with you. So you're tired? Vous êtes fatigué?
Mr. Ernest.
Oui.
So in an instance where you've been given a question like this one, are we supposed to ignore what the brackets are saying as long as we don't have an interval or a segment? Are we supposed to ignore those?
You actually, here we haven't actually ignored, because we've used these brackets when describing the plus grand element and we're describing the plus petit element. We've actually used them.
But isn't it that that one was closed, but we ignored the fact that it's closed?
This one?
The first one.
No, wait, no, I was saying, for example, how did we come to realize to say we have the true Gondelemo AC? Because we had the closed bracket. I even said, because we have a closed bracket, we can say 1 is the highest in this range that we have here. 1 is the true Gondelemo, and because it's a closed set, we have the true Gondelemo, the true petit element for a crazy, so we actually had used these sets that we have here. C'est bon?
C'est bon.
So do a lot of questions. For those that want a lot of questions, yes, you see, I have 1,000 questions on mineral, majora. I would prefer you do a lot of questions on this, because when you start looking at suites, the next topic that you're going to be looking at probably next week, if you don't get this concept here, analysis is going to be kind of messy for you. Yeah, it's going to give you some problems. So in case you need any clarity, any questions on this, just easy, because I've seen you guys are tired.
What
Unless you're not tired.
What is
Should we continue?
I think
yes, we can continue.
Pardon, just before the question, I'm asking,
yes, we can continue.
Should we continue? Before
Yes.
this
One.
Yes, let's continue.
All right. Thank you. We are going to, we'll just wait, we'll just solve for 18 minutes, then we'll be done. No, 18 minutes. 18 minutes will be done. Yeah, there's a question.
Like we need to compare.
No way, that's too much.
Okay, that's too much.
So what we'll do now, okay, so what we'll do, I've left a question here. I haven't solved one question here. The only person that has already sent me this question is, I've explained everything here. So everyone should send me this question by Sunday. If you don't solve me this question, the rest of the TDs will never do it with me. And I'm very, very strict on that. Solve this question. And the majorant, this one here, this one, the remaining one, on the majorant, mineral, la bonne supérieure, la bonne inférieure, for this expression.
What of that N?
We have solved this one.
Oh.
So what we're solving is not for the last one, it's for the N.
Then what were we solving for?
We are solving for N. Natural number. Even when we are solving. It's grave, eh?
Okay, so on the same one, we don't have majora there.
I don't know. C'est pour vous, c'est pour vous, c'est pour vous.
I thought maybe Ruben was explaining the last one.
No, he was explaining for this question, natural numbers. He was explaining for natural numbers. He didn't explain for this. This is a different question. Ruben, we are solving this question. I told you I made a mistake. I was trying to solve this one together, this one, but I discovered there are actually two different questions. So it was my error. Pardon me for that, Subukle. Okay. C'est bon. So this one here. So yeah, Sunday, everyone should send me by Sunday. Sunday, 12 hours is the maximum. So that I'm able to check your work. By Monday. Yeah. So solve me this.
Like, is it like the question isn't it just the same?
It's the same, yeah. You find the majorant for this expression, the minorant for this expression, la bonne supérieure, la bonne inférieure, le plus grand élément.
Like the answers are some are the same, because the only difference in the last question is that we got an exception.
Attention, c'est un devoir. It's a homework. So me, I don't know if the answers are the same or are not the same.
Why not on Sunday 23 hours?
No, Sunday 12 hours.
think that's a bit too early, don't you?
Yes, I don't know how you're going to use your time, show. Because Sunday evening, more is a problem, and I have programs also, so it's supposed to be a time that should suit me and you. So I've discovered Ruben has told me to say Sunday 12 hours is okay for everyone. So it's
okay, we shall send them Sunday.
Inshallah. Merci beaucoup.
Yes, Sunday is just fine.
Sunday is okay. Merci beaucoup. Merci. Bon. Okay.
Are we solving the next question or we are done?
We are done.
No, we're still, no. You guys said we should continue solving. So we're going to solve. Yeah, but this one is going to be very, very simple. We're going to solve exercise 6. Okay. Bon, how complicated is exercise 6?
Yes.
You guys already told me give you something that's going to be easy to understand. Okay. Bon, maths now. We should cancel exercise 3. C'est pas quelque chose qui est bon. We can solve. Let's solve exercise 7. Donc soit f r. Have you done functions? No, not yet. But we can solve this question. This one I'm supposed to understand. Do you remember functions from Zambia?
Exercise 6.
Exercise 7.
No, I don't remember.
David.
Let us just solve
Let's try.
Okay.
Let's just say bye.
Okay, so we solve. I know you guys are tired, but we don't have time again. That's a problem.
Yes, we
can solve.
Okay, let's solve exercise 7. So exercise 7, we're going to solve it in the plus facile manière. So we have so f being a function, and in this function it contains real numbers such that for all members of x and y belong to R et 3. Pourquoi R et 3? It's because we've got two different forms of x and r. If I was to stress this, I was going to have your y-axis and your x-axis. So maybe we have a point that is here. So we have a point that is here. Probably this point is going to come up. Okay. So this is what this is trying to describe, which is that here. So pour tout x et y appartiennent à R et 3, ça veut dire qu'on a deux variables, f de x plus y égale à f de x. You expand a simple expression of this one. Gives us this. You have f of x plus f of y. First question. Montrer que pour tout n appartient à un nombre naturel, f de n égale à n fois f de 1. Okay. Very, very simple question. Very, very simple. So for the first thing, what do we do here? We are going to calculate d'abord. On va commencer avec la calculation pour faire. D'accord. Since I have real numbers, n'est-ce pas? So I'm going to say, on va supposer, si on a ici, here we have f of 0. We suppose, si on a f de 0, ça veut dire quoi? F de 0 here is going to give us what? We suppose that n is equal to
give us
0. N'est-ce pas? It's going to give us 0. Très bien. That's for question 1, n'est-ce pas? F is going to give us 0. Ça veut dire que we know that f of 1 is going to give us what? It's the same as saying f of what? If we say f of 1, it's the same as saying f of what? We have our x variable that we have here, which is what? Which is 1 plus, what's going to be our y variable? What's our y variable? You people, this is math that we used to do. Our y variable is going to be 0. You don't remember the function that we have, f of x function is equal to what? Right. And this is what we found here. So when x is 0, we found here. When x is 0, we're going to, so this is your f of x, not your x function that you have here, and this is your y. So your y that you are having here is 0. We replace 0 there. So we're going to have f of 1 is equal to f of 1 plus 0, and f of 1 plus 0 is equal to what?
F of 1.
F of 1. Ça veut dire que f de 0 égale à 0. So this function has been proven to be right. We continue. Donc, qu'est-ce qu'on va montrer maintenant? On montrait maintenant que les résultats demandaient des récurrences. Recurrence, you did this probably in algebra. So recurrence is you are going to be replacing. So you replace and see what values it's going to be giving you. So it starts with n is equal to 1, n is equal to 2, n is equal to 3, up to the number that you feel it's sufficient for you. So what if we suppose n will be equal to 1? From this function that we have, if n is equal to 1, what are we going to have? We're going to have f
of 1.
The r, which is going to be equal to 1 times f of 1. And f of 1 will be equal to what?
F of 1.
F of 1. Ça sera juste la même chose. Donc, si on a cette fonction, so if we have this function that we have here, alors, si on a, bon, I hope you have written down this because I'm about to rub. Oui, j'espère.
I don't one lost.
No, you're not.
No, we are a lot.
Ça veut dire que si on, donc ici on a f de n, so that's the first function f de n. So if you have, for example, a sequence, we have n sequence here. What's going to be the next sequence? N plus 1. Ça veut dire si on a f de n, on va avoir f n plus a qui est égal à n plus a de f de a. Voilà. You have that. So we can, bon, pardon. We have one here. We have one here. Sorry, pardon.
And we are lost.
Yeah, you're lost. Hey, but you guys are just quiet. I couldn't even get you. I was even thinking I'm talking to myself. Where are you lost? You should be free. Don't like just be free.
Just from where you started.
From the beginning.
Joseph.
From the beginning.
Ah, from the beginning. Bon. Normally more time is already up, but 5 minutes I'll be able to explain everything. Okay. So I'll just solve the first question so that you guys can solve the last 3 questions, and then you send me with the Sunday work that I've given you. Okay, so here, the first that you have, let me just rub everything. Okay. Please stop me when you don't understand. Just stop me. Stop just there. Don't go anywhere without.
Oh, but Wakamba, just to be honest, even if I solve the first question, then you said I shall solve it. It's like for me, a poem to now jam, so it won't be possible.
Sorry? Well, you're saying something, but I didn't get it.
Oh, guys in Zokamba team. Right now, with him, it's not happening because him solving at the first question and leaving the rest for us. It can't work. He's confused. Très confused.
Confused where?
No, it's not saying that he's confused, but he's tired. Like, yeah, just like me.
In that sense, you guys are tired.
But maybe before we go for a question.
Okay, bon, okay, on va faire comme ça. Alors, I'm not going to explain on this one. We're going to do it next week, I think on Friday. So we'll leave time for questions. Any
Yes.
questions?
Yes, I have a question. On the same exercise 7.
Oh, wait, no, exercise 7. Don't ask me. No, this one I'm going to come and explain it down because people are tired, and I would like.
No, I just want to know the language there. Why it says swa? In English, is it the same as given that, or maybe it means?
Yeah, it's given that. Yeah, it's the same.
Oh, I thought maybe it means is.
Yeah, that's so some can just say given that a function which has got real numbers, and every time you put anything in that real number, it is your number. You're going to understand this form very well when you do functions. Don't worry. And I was still asking myself if I should really solve this question with you. Yeah. Oui, d'autres questions? Is it because you are tired or you just don't have patience?
This A that is upside down. What does it mean?
Okay, so I'll repeat myself for the last time. Me, I always tell my students every time I teach the guys, I always tell them what really is essential. So questions that rarely miss in the exam are these. For those people that are doing business, and if I'm saying this, you should be taking notes so that you work more on them. This question here, this question, jamais, never misses in an exam. Okay, c'est impossible to miss an exam normalement. Even though it comes to on a different application, c'est obligatoire. You should know this question. This question, exercise 5. You should also be bon. This one, ça va dépendre. Yeah, but normally this one you just solve it in the core. You don't really get to find things like this in an exam. Yeah, but the most essential one actually in this TD was this one here. This question, exercise 5. Very, very essential. For engineering, for those that are going to do GGM, mid, answer, yeah, this is going to be explained for you in class, but I haven't really found it something that is very difficult in an exam or really coming on an exam. Okay, but s'il vous plaît, this question and this question, very, very important. Okay. Okay.
Question 2, exercise 2. Can you solve it like using other method, or you solve it using one method?
We you can solve it. None I'm saying we can't really solve everything here. Okay. None I was saying in case you have any different way, you all have my WhatsApp number. Just inbox me. Oh, okay, boss. I was trying to look at this question like this. Ideas, or if you haven't not clear, you can come. We can have. I can make a Zoom meeting with you. We discuss together, and then it becomes sort of. What I want is everyone to understand. So if you don't understand anything, just text me. NSO, I didn't get to understand this part. I'll make a rendezvous with you. I explain every bit, people are different. There are people that understand when in a group, but there are some that understand individually. And I always work with any different kind of people. Okay. So me, just follow me and tell me, oh, NS, unfortunately, I'm not that side, but we can always make a meeting. You bought this license, so I can make a meeting at any time. So I can say, okay, if I'm free, I'll tell you, okay, at 19 hours, we're going to solve questions like this. If you find questions on the internet, just tell me, oh, NS, I found this question, we solve together. This is for you guys, it's not for me. Me, I'm already done with these things. Okay, so just be very, very free with me. I always find it difficult because a lot of people don't really get to be free and everything. But trust me, as long as you're going to be free with me, you're going to solve a lot of questions and ideas. Okay, it'll be a testimony. So if you don't understand anything, just tell me. We make a rendezvous ensemble. On va faire. C'est bon?
Oui, c'est bon.
Oui, c'est bon.
Okay. Donc, il n'y a aucune question maintenant, non?
Si.
Okay. So try to go through the work. Yeah. before you, of course, come to me and say I didn't understand. At least you should have ideas of what was happening or what's going to be happening as we start together. Donc, merci beaucoup, bon courage. Your TD2 is going to be out probably next week. Let me just, because normally I make, so let me just make it and I'll send out this. The question is, I think next week, I'm going to give you your second TD on suites. That's where analysis starts. Instead of analysis, it's just like basic stuff, like alphabetical order. I haven't even started solving questions. Merci beaucoup et bon courage.
Merci beaucoup.
Okay.
Merci beaucoup. Mr. Ernest, have you given something to solve? Like some questions?
Yes. I said you should do this question. You should do this question. If you have a problem, s'il vous plaît, venez chez moi et je vais te donner this question here.
Number one. Oh.
It says 5, yeah.
Only that.
Okay. C'est bon. Okay, merci. I'll terminate the meeting now.